Hi, I'm Kaitlin.
And I'm Gabrielle.
And we are in ECE/MAE 535, and we are doing a demonstration project on LVDT. And let's get started. So what is LVDT? LVDT stands for Linear Variable Differential Transformer. Our circuit looks like this and can be represented with our little LVDT prototype. It is used to take the linear position of an object and convert it to an electrical signal. Some of the things that it can be used for are things such as automation, hydraulics, power turbines, but also aircrafts and satellites. The LVDT uses magnetic coils and ferromagnetic core, as long with this metal rod. The middle and left coil are wound in the same direction, while the right coil is wound in an opposing direction. There's an AC signal on the middle coil, and that's going to use magnetic flux to induce a voltage onto the two secondary or outer coils. Due to this, the magnetic core is moved. When the magnetic core is moved to the right, the AC signal becomes inverted or has a phase shift by 80 degrees, and the equation representing this becomes E out equals E2 minus E1. Conversely, when the core is moved to the left, the signal is amplified and changes the equation to E out equals E1 minus E2. And then lastly, when it's in the middle, the E out equals 0, and the left and right coils will cancel each other out. The materials that we used were 34 gauge wire. We used a 3D printed cylinder. This isn't a cylinder, but we do have one for the actual demonstration. A ferrite core and a rod. Ours happened to be metal. Gabby will explain more about the process on how we made it and our results.
Thank you, Kaitlin. That was most informative. And on to the instructions. As Kaitlin said earlier, there are 3 coils. The outer 2 coils are the secondary, and the center is the primary coil. We taped them together so that to not cause any interference, and then we connected the primary coil to the waveform generator of the Analog Discovery 2, and the secondary coils, we connected that to the oscilloscope on the Analog Discovery 2. We inputted 100 kilohertz, 5 volt sinusoidal wave, and on to the results. When inserting the ferromagnetic core on the right, the amplitude will increase slightly. As it goes further from right to left, the amplitude will continue to increase. The voltages are lower than anticipated, ranging from 85 millivolts to 171 millivolts, rather than from negative 10 volts to 10 volts. We see the amplitudes changing in relation to where the ferrite core is, but when the ferrite core is in the center, the signal does not cancel out like it should, and the AC signal does not match the waveform generated from the primary coil. Now that you guys seen our results, it's time to talk about the reasons and why our LVDT didn't work out as we planned. One of the reasons could have been how we wrapped the wire around our cylinder. The distance between the coils could be too large, the windings could be too loose, or there could just very well not be enough windings for each core. And another problem that we could have had or could have been was the ferrite core could just been not strong enough or not what we were looking for. And now it's time to go to our end credits.
So that was our video. I hope you enjoyed. If you have any comments on what we could have done wrong, please leave it down below.
And make sure to check out our other video in the description. It's a hoot.
Yeah, it is our blooper along with our song. So hopefully you enjoy that too. Bye.
Bye.